Let's discuss polynomial functions. The goal for this lesson is to identify power functions and polynomial functions. Then we will graph polynomial functions, then write a formula for polynomial function from a graph, and then determine equation of polynomial given key information. Now let's define a power function. A power function is a function with a single term that is a product of a real number, a coefficient, and a variable raised to a fixed real number. And an example for that would be this function here, where you have a function a of r is the variable here, and this variable r is being raised to a power 2 and a coefficient of pi. Another example would be the function for the volume, denoted by v. This function is a function of this variable r, and 4 pi over 3 is the coefficient. R here is the variable raised to a power 3. Now, in general, a power function is a function that can be represented of this form, f of x equal to constant times the variable raised to a power. Both k and p here are real numbers, and k is known as the coefficient. Now consider this function f of x equal to 2 to the x. Is this a power function? The answer is no. F of x equal to 2 to the x is not a power function because the base here is constant and the power is a variable. This is not a power function but rather an exponential function, which we will discuss in the next sections. Now consider the given functions here. Which ones are power functions? We have here 2x times 4x cubed. If we combine all of the variables here and the constants, this first one is just equal to f of x equal to 8x to the 5th. So you multiply 2 and 4, multiplying 2 and 4, that gives you 8. And you combine x and x cubed, that gives you x to the 4th. So this one should be 4. Now consider the following functions here and identify which functions are power functions. F of x is equal to 2x times 4x cubed, when simplify, is just equal to 8 times x to the 4th. That is by multiplying this 2 and the 4 here, that gives you 8. And then x times x cubed, that gives you x to the 4th. Now, these two other functions, g of x and h of x, are not power function because you cannot combine these two terms here. They are unlike terms. You cannot combine them to a single term. A power function, again, is a single term with a coefficient and a variable raised to a power that is a real number. This is not a power function because you have here a numerator and a denominator. You have a rational expression here. Now let us define a polynomial function. Let n here be a non-negative integer, so it's a positive integer. Now a polynomial function is a function that can be written of the form a sub n times x to the n plus asterisk. This triple ellipsis here means that you continue to add this type of term until you reach a sub 3 times x to the cube plus a sub 2x squared plus a sub 1x plus a sub 0. To simply put, a polynomial function is a function whose terms are power functions. These are power functions whose powers or exponents are positive integers. So the exponents should be positive integers. The coefficients could be any real number. Now let's consider these functions here and identify which of the following are polynomial functions, or which of these functions are polynomial functions. So if you consider the first one, f of x is equal to 3x cubed times 3x plus 4. Now you can write that as 6x to the fourth plus 8x cubed. So we're able to write this in a form whose terms are actually power functions. So therefore, the first is a polynomial function. The second one, this g of x equal to negative x times x squared minus 4, can also be written as negative x cubed plus 4x. Hence, we're able to write each term here as a power function whose powers are all positive integers. So therefore, these two functions here, or this function g of x, is also a polynomial function. Now, h of x equal to 5 square root of x plus 2 cannot be written of this form here, cannot be written as a sum or difference of two power functions. Therefore, h of x is not a polynomial function. Now let us consider this example here. Is this function a power function, a polynomial function, or neither? This function here is a power function because it has a coefficient and it has here a variable raised to some power that is a real number. So that is a power function. Now, is that a polynomial function? This is not a polynomial function because the power here is negative. If this happens to be positive instead of negative 10, that's a positive 10, then that is also a polynomial function that has only one term. But since the power here is negative, it is not a polynomial function. In fact, if you simplify this, this is actually equal to 12 over x to the 10. That is not a polynomial function. Now, what about this function here? Is this a power function, a polynomial function, or neither, or both? Now, this example here is obviously a polynomial function because each term here is composed of a power function and also the exponents are all positive. So that is a polynomial function. But is this a power function? It is not a power function because it is composed of several terms. A power function is only composed of a single term.